Hello, everyone. Today we will be talking about material design. What is material design? Probably after 5 years, most of you know. It is a design system. And there's something going really wrong with my slides. 1 second. Okay, this is better. Yes. I am Sebastiano. I work at JetBrains. And again, today we're going to be talking about material design. All of you know by now, after 5 years, material design is a design system. Or actually, maybe it is a design system. The reason why I'm making this distinction is that last year at Google I/O, they announced material theming, which is basically saying, okay, we gave you an idea, now go and run with it and make your own design system based on our design system. And Google themselves have their own version of material theming. But what I'm going to be talking about is not specific to any of those themes, but is a general thing about the core essence of material and what that means for Android developers. Material design is based on a physical metaphor. That physical metaphor is that there is paper and ink. And we will see this is not skeuomorphism. Luckily enough, it's not like iOS 6 and stuff like that. That's gone. But the material design is called material because the main concept of material design is the material. The material is essentially a metaphor of physical paper, kind of, with a fixed shape in most cases. And that shape, though, can be any shape, and the size can be any size. A material can literally be an infinite rectangle with a fixed width and an infinite height, which is what is the abstraction behind, for example, an infinite scrolling list. And it reacts to light. What does a material that reacts to light do? It reflects the light, so you can see it, and it obstructs the light, so it casts a shadow. For example, this is the wireframe, let's call it, of what you would see on a generic app on your phone, on your device. You can also have movement, and that's another of the tentpole concepts of material design, meaningful motion. Material sheets can move around and do move around. An example are bottom sheets, which slide up. An example are fabs that move around, can go up, can go down. They do what they want. And they can also change parent. Let's call it parent. Basically, when you have something in material that's generally positioned relative to other stuff and should logically move with that. But sometimes, for example, in shared element transitions, that's not necessarily true. And you could have things that move from one sheet to the next because one sheet is, say, one activity and the next sheet is another activity, and stuff moves to a different parent, let's call it. But there's also color. It's not just about black and white. There's color. There's a lot of color. And the color is represented by the concept of ink. And now we basically have this magical ink on magical paper. So it's a magical design system. That's the takeaway. The content on any sheet is ink. And the ink generally, well, ink has a color, whereas the material, the paper, is generally white. You can have sheets of paper that are entirely colored, but that's generally intended as this is a sheet that is fully covered by ink. And ink, contrary to the material itself that cannot change shape, the ink is more magical because it can actually change shape. Think animations, think about anything that moves inside of a specific sheet. Now, material is also expressing itself as a physical metaphor, and as such, there is a physical space, a physical environment in which everything exists. For example, any sheet have the coordinates. The sheets are, well, like paper, they're essentially 2D, and the ink on them is 2D. But the ink is positioned on a sheet with a set of coordinates, and those coordinates have an X and a Y coordinate like we are used to in computer graphics. And as in computer graphics, at least on Android, those coordinates start on the top left corner of the sheet. But there is also a Z coordinate in this environment, in this physical space, and that is actually 0 for what we can call the background sheet of your device. So the bottommost layer of material upon which everything else is displayed on. You can think of it as the back of the display in a way. It's kind of a weird metaphor, but that's it. And then you can also have other sheets on top. Well, you generally have other sheets on top, and those sheets have a Z coordinate that is either 0 or positive. The Z coordinate is called elevation. We have all used the Android elevation attribute at some point, or the corresponding API. And as we all know, elevation in Android is measured in dips. Now, you can animate the elevation with the translation Z property. It is the same thing as translation X and translation Y properties, but it's not called elevation translation. It's called translation Z, I guess, to make it a whole with the rest of the translation properties. And with this, you can actually move stuff up and down, make it come closer to the viewer or getting more towards the background. Now, this is a physical environment, and as such, there must be something. We mentioned that material interacts with light, but where is that light coming from? There are two lights in a material system. They are positioned relative to the background sheet, let's call it, or the screen itself, and they have coordinates. Well, one of them has, which is a point light, well, it's a spotlight, really, and that is positioned 600 dips above the screen and is a circle with 800 dips diameter. Assuming that your screen is 420 dips wide, then that would be the relative size, give or take, minus the perspective. But just to give you an idea. And that's big, and as such casts diffuse shadows. And there's also an omnidirectional light. An omnidirectional light is a simplification of an infinitely distant light source. For example, it could be the sun, which is so far away from us that we all see, all the light rays are effectively parallel. And that is, again, it's an abstract representation, and there is no real position, and it's thus an infinite distance from the screen. Now, looking at how the environment is from the side, not to scale, and let's see what happens when we have a piece of material that is displayed on the screen. Well, what does the shadow look like? To do that, you have to draw lines. And then you will see that the actual shadow that this element is casting is the region that is comprised by taking those lines straight down from the edges of the light. But that's not all, because there's also an area that is partially obscured by the element, because part of the light has a physical dimension, and thus all the points in the light emit light, and all the points in the light emit light rays. So you need to. It's not a sharp shadow. It's what you would normally see as the blur property of a shadow, say in Keynote or other software. And that's determined by the size of the actual shadow casting it. So now you know that. So we turn on the light and we get this shadow. You can see there's two parts. As I mentioned, there's a part that is completely dark, which is the center of the shadow. And there's a part that is partially obscured and is gradually going to transparent. And those are called respectively, umbra and penumbra. Now, if I showed you something on Android, say a card or any visual element, and I said, you have an elevation of 5 dips, I don't know, something like that. Now, I can tell you that here, I'm actually showing you both a spot shadow and an ambient shadow. You don't really see them, so let me help you. I'm going to make one blue and the other one red. Is that better? Not really. So I'm going to make them more blue and more red, so you can actually see them. You can kind of get an idea of the ambient shadow surrounds the edges of the element that is casting the shadow, whereas the spot shadow is a larger shadow, is bigger, is more pronounced, and is also not exactly aligned. It's a bit towards the bottom of it because the light is at the top. So it's casting a diagonal light down. And if you want to see them separately, it's even clearer at this point that the ambient shadow really is what results from an infinitely distant source of light because it's positioned exactly around the element, whereas the spot shadow is moved around a bit. But why is that moved? Well, as I mentioned, the light is at the top, is over the top edge of the screen. So when you cast a shadow, then you will see that you can notice that the shadow and the element that casts the shadow are not centered with each other. Because if you draw the lines, then that's what physics gives you. And if you move the element more towards the bottom of the screen, you will actually notice that the relative position between the element that casts the shadow and the shadow itself has actually shifted a bit more. So the shadow is relatively more scroll down. And you can say that the spot shadow goes down as the y coordinate increases because of the properties of the light itself, the light source, and the position of the light source. So to be a bit more precise, you can see if we just trace where the center of the umbra and the center of the caster are, it's even more clear that as you go down, the difference between the two increases. Now, in Android, shadows are always entirely black. They have a color set by default to 000000, and the alpha is fully opaque. But then, why are the shadows that you see on Android so subtle? Why is that not like very dark? That's kind of like a light gray sort of a shadow. Well, there's a reason for that. In the default themes in the system, the ambient shadow is only 3.9% opaque, and the spot shadow is only 19% opaque. So at the end of it, it's never going to be very dark. That's an explicit choice that was made when designing shadows and how they should look. Except on TVs. On TVs, I don't know why, but I suppose for reasons of usability and being able to see those shadows on a screen that is farther away from you, they're actually more opaque. They're like 15% and 30% respectively. Can we control the shadow, though? Because shadows are cool, but wouldn't it be cooler if you could do stuff with them instead of just having them? Well, there's one obvious way to change the way shadows look, and that's elevation. The elevation just makes the shadow bigger or smaller because as the item gets closer to the light source, the shadow that is projected gets larger. And as it gets closer to the surface that the shadow is projected on, then the shadow shrinks. Elevation, we have seen, is the Z coordinate. So it effectively changes not just the distance between the shadow caster and the sheet that the shadow is casted on, but also between the element that is casting the shadow and the light that sits above it. And this also impacts the amount of, let's call it, parallax that we have seen as you go down the y-axis for the spot shadow. So our example from earlier, we had a 2 dips elevation. So we start with this situation. We've seen there's a small difference between the center of the caster and the center of the umbra. We go to the bottom of the screen. There is a kind of double. This is made up. It's not to scale, but just to give you an idea. It's a larger difference, and thus we have a delta in position of the center of the shadow compared to the center of the item that is casting it. What happens if we have a 10 dip elevation, though? As you can see, the shadow is, first of all, much larger because physical properties. But if you move if you move the item to the bottom of the screen, as we've done before, you will actually notice that we moved it less than before, but the coordinates, the delta between the center of the caster and the center of the umbra that is casted has increased a lot. And the effective delta that we get for a higher elevation is much higher than the shadow itself had when it was smaller. Sorry, just got caught up there. In Android, to project a shadow, you need an outline. An outline is an API that was added in Lollipop when material design was ported to, well, launched and ported to Android. Outlines are quite a simple concept. They're basically an item representing a shape and an alpha value. Outlines provide a shape, and that shape and that alpha are used by the operating system to say, oh, this item has a bounding box that is a rectangle, like everything, but actually the contents are not a rectangle. They're like a rounded rect, they're a circle, they're something else. And so it can do stuff like clip in the background. It can do stuff like occluding light. What is light occlusion if not shadows? So outlines are actually used by the operating system, not just for clipping the contents of a view, but also to decide and understand what the shape of the content is, and thus what the shape of the projected shadow should be. All views have an outline, and that is not a static property of it. Views have an API that is called View Outline Provider. And View Outline Provider is a very simple interface that you can implement that has a single method that takes in an outline and returns an outline. Basically, you get in an outline that is the default one you would get normally, and you can do stuff with it. For example, you can have different shapes. Outlines, in general, have a number of possibilities for what concern the shape that they represent. Not all shapes can be represented by an outline. In particular, you can have an empty outline, you can have a rounded rectangle, and you can have a generic convex path. Concave paths are not supported because they throw up a lot of optimizations that are done under the hood to make shadows actually performant enough to work. And we'll see some of that creeping in when we play around with shadows a bit more later. Now, you will probably wonder, what about rectangles? What about circles and ellipses? Those are definitely something we see often. Well, it turns out those are simply rounded rectangles. A rectangle is a rounded rectangle with a 0 corner radius. A circle or an ellipsis is a rounded rectangle with a corner radius of max int, or whatever the value is, but big enough for it to not have a straight path, but just be completely rounded. And in the case of views, views by default get the outline, and thus the shadow they produce is dictated by their background. The background of views are always drawbles, we know that, it's always the same thing. But there are different kinds of drawbles, and all different kinds of drawbles handle outlines differently. And if you do custom drawbles and you need to have an outline and the shadow casted by something that has your custom drawable as a background, this is something you need to take into consideration. You need to override the method that generates the outline for the drawable. So the base drawable is the simplest example of them all. It's like the class drawable. That has an outline which is the same shape as the drawable itself. It's just a bounding rect, but it has a 0 alpha property. So basically, it will not cast a shadow. It is there, but it's not doing anything. Bitmap drawbles kind of do the same. They are saying, oh, I have a bitmap, I know the size, so my outline is the bitmap itself. except if the bitmap is not fully opaque, then the outline that the bitmap drawable generates has a 0 alpha. So basically, if you have a bitmap that is like a PNG, and that PNG has some transparent areas, then the outline for that will have a 0 alpha. Because Android, again, there's a limited amount of shapes that outlines can support for performance reasons. And you cannot really support arbitrary shapes of bitmaps. So they just decided to, well, we're not going to do it, basically. Shape drawables, they're smart enough. They are shapes. All the shapes that are represented by a shape drawable are supported by outlines. That is definitely not a coincidence, because outlines were made after shape drawables. And then we have a bunch of other less commonly used drawables, but are still quite important. So, for example, layer drawable and transition drawable, they behave the same way. They basically look up the stack of all the bitmaps that they have wrapped and go from the bottom to the top and find the first one in the stack from the bottom that does have an outline, because bitmaps can, like drawables, can also not have an outline. They can return null. So in that case, it says, oh, first one doesn't have one, second one doesn't have one, third one does. Good, let's use that one. In the case of state list drawables and level list drawables, they simply say, oh, this is the drawable I'm currently displaying. I'm going to use its outline if it has one. Yeah, otherwise, I don't have one. 9-patch drawables, if anyone is still using them, they're bitmaps. So you would imagine they behave the same way, but at the same time they can stretch, and that's a bit weird. Basically, when you compile, AAPT generates what is basically used as an outline. So it says, oh, here's a rounded rectangle. In practice, it is a rectangle that matches the bounds of the 9-patch itself. But you really don't want that to be, like, you really don't want to use bitmaps to cast shadows, because it's just a mess. And as an alternative, if you have defined optical bounds, which were introduced in 4.3, I think, then it will use those ones instead. Next up, we have Inset drawable. It just takes whatever is inside of it and uses its outline. Easy enough. And then you have drawable wrappers, which are a family of other drawable built-in types that are in the operating system. And they basically do what you would expect. They take the outline of the wrapped drawable, or they take the default 0 alpha drawable bounds that the base class drawable would return. Examples of drawable wrappers are rotate, clip, and shape. No, shape, no. That's a mistake, sorry. Shape actually does override that and has the behavior that I mentioned at the beginning. So can you actually manipulate outlines? Because, well, you think of it and you say, okay, I have a view, I have an outline, well, the view has an outline, and that casts a shadow. But what if I have a designer that really hates me and wants my views to have a slightly different shadow from what you would normally get with elevation, which happened to me? You can swap and you can tweak the outlines. You can basically do this with just taking a view and assigning a custom view outline provider that returns whatever you want. There's many possibilities at this point. For example, you can change the shape of the shadow. For example, you can say, oh, this bitmap that I assigned is semi-transparent, so it won't have a real outline, but I know it's a circle inside, so I can just tell you that the actual circle there is this. And thus you can have an elevation shadow even though you're using a bitmap. An example could be like in fabs. If you're using PNGs for the background of the fab for whatever reason, don't do that, but if you do, that's how you fix it. And you can also change the size and the position of a shadow. For example, you could have like a slightly more pronounced shadow, or you could have something that is like this is slightly shifted down, slightly shrunk, is a bit narrower than it would be otherwise, or you can go overboard and have something like that with a very high elevation value and just shift it down and shrink it even more, so it looks a bit weird and makes things pop up more. You don't generally need to do this, but if you need to accommodate a design, or if you want to have something that specifically looks a bit different from the rest of your UI, this is another way you can get that. But you need to look out for artifacts, because the rendering of the shadows is highly optimized, and at least until Android P, well, Android O for sure, it was done by the old hardware accelerating rendering system, which is called HWUI. And that was taking a lot of shortcuts to make the rendering. So if you go overboard, that's not like a nested shadow. It's just like the one elevation shadow that I tweaked too much. And that's something you really want to avoid. What you generally can do is you can shrink the shadow a bit, you can increase the elevation, maybe you can shift it up and down a bit and see if you can get something closer to what you want. I know there's new stuff in Android Q that you can use, but I haven't played with it, that should allow you to get around that, because in Android Q you have access to the render node itself, which is what the operating system and Skia, in this case, directly use to render the shadow. So you can really do whatever you want, and you can get around all those limitations. So what about colors? Well, material specs don't say anything about shadow color. But in reality, those shadows are always black, as we've seen, as we are used to seeing on our devices. There is no way practically to control the color. But actually, there is since Android Pie. So the latest stable version of Android allows you to play around with colors and make things look nicer. For example, the new APIs that you get with API 2028 are allowing you to set the spot and the ambient shadow colors. And those are called outline ambient shadow color and outline spot shadow color. Those are the XML attributes, but you can also use the set outline ambient shadow color and set outline spot shadow color methods in code. The documentation is very clear, mentioning that the colors should really be opaque. And there's a reason for that, and we'll see it next. But we have a red, we set everything to fully red, and we still get that like, meh, kind of like not really red, it's meh color. Sure, there's a background that is not white, but it doesn't look much better on white. So what about that? If we look at this and we think about it, it's like it looks like that because the alpha of the shadows, as we've seen earlier, is very low. The alpha we have seen and we've said is controlled by a theme. And there are attributes in the theme starting from Lollipop, obviously. And those are ambient shadow alpha and spot shadow alpha. Those are actually what the TV theme uses to make the shadows darker. They can do it. Why cannot we do it? So we look at this shadow in detail, and we try to understand what's actually going on. For the sake of argument, for now, we'll just keep it black because it's easier, and then we'll see how it actually works with color. So the documentation says that the shadow opacity is actually an emulation, a simulation of what happens in physical reality because of the distance of the shadow caster. The light is very distant, it's 600 dips, it's very far away compared to the size of the screen and the size of the element, and thus the shadow is not that opaque. It's kind of diffuse. And then this is in reality is mapped to the fact that we have these attributes in the theme. These attributes actually mean to represent this physical reality in code. And then what we do is we have the color that we get from our outline spot shadow and outline ambient shadow colors. And that is actually multiplied by the theme alpha factor. And that is why we get a very light alpha, a very light shadow. Because when you multiply that, you have the color you had, but with the multiplied alpha. And that is why the documentation says that your colors should always have a full alpha, because if you have a non-fully opaque color for the shadows, then the multiplication will actually bring it to a level that is like almost invisible. If you do it with red, then we change our color to red, and then our shadow becomes like that, like red, as we've seen. Now, the right amount of alpha that you actually should use really depends on the colors, not just of the shadow, but also of the background. Say we have a bunch of items and we color their shadows. You can barely see that their shadows are colored on white, but it's even worse if you have a colored background. In this case, it's basically impossible to tell them apart. They all look the same. So what you might want to do is you might want to have different values of alphas for all of them to have them actually visibly different. But there's a problem, because we've said that the alpha is actually dictated by the theme, and themes don't change. You cannot change them at runtime. There is no APIs for that. And they are also applied the same to all the views. Now, it is difficult to have only some shadows being colored. Say, for example, the designer says, oh, that big purchase button at the bottom should really have a red shadow because I want it to stand out even more. The problem is that if you want that to look good, then the rest of the UI might not look good. Because, say, we optimize for that, and now suddenly all the shadows on the rest of the activity are really pronounced, and that's not good. On the other hand, if we use the correct value for the rest of the activity, our red shadow is basically invisible. You can hack around it, though. That's the good news. Theme overlays are a possibility. I've never really tried it because it sounds like a lot of pain, and it's probably most likely not worth it. But there is a better way, which is what I'm here to tell you about. So looking at the genesis of our final shadow color that we have seen earlier, we can see that there's two main factors that determine how the shadow will look. First is the alpha that is set in the theme, with the two attributes there. And the other one is the color of the shadow, which is set by these other attributes. Now, the theme, as we have said, impacts everything. Everything on screen is impacted by the theme, at least everything that theme is applied to. And it's a pain to change per view. If you wanted to go and play with theme overlays, like you're gonna screw it up at some point, and you still have no runtime control. And besides, themes and styles are wrong. Like, everyone does some mistake at some point. It's inevitable. So what if we focus on the other factor? What if we focus on the shadow itself? Shadows are easier to use. There's runtime control because there's APIs for that. So we can say, oh, we can only change the shadow color for that view, which is also more intuitive. It's like everything works normally, but that one is special. And we can also change them at runtime. Now, the trick is to set the alpha for the shadows in the theme to 1. If you set that to 1, then the alpha is now fully controlled by the color itself. And the color, we said we can change it at runtime. So in our example, we could have a fully opaque red shadows. Now, we can also have a lighter shade of, we can have a lighter opacity on the color we set. And at that point, well, we're fully controlling the shadow color because the color itself is the only factor left in the equation, and then we have full control over that. We need to do some prep work around it. First of all, we need to make sure that we set black with the pre-multiplied alpha value in the theme. That's the default that you would get for the material colors. Just use those and set them in your theme, and you're fine. We said, though, that we can only do this prior to Android P. We are only going to be considering Android Lollipop and later, because if you're doing before Lollipop, I'm really sorry for you, but you have bigger fishes to fry. The only knobs that we have from 21 to 27 included are the alpha of the shadow. And changing those by themselves is not particularly useful because things really do end up looking weird if you do. So the only thing you can do is using resource overrides. You have your base theme with most of the stuff in the rest values. You have a theme for 25, 21, 27 in rest values. And then you have a theme specifically for 28 and later in v28. And you only change the shadow colors and anything else in the 28 theme. So you will not have fancy colored shadows pre-28, but that's the best you can do. So let's tie it all together and close this up. There is an application that is open source that is on my GitHub that is called Uplift, from the that you have seen in the title of this talk. This one is an application that is basically a playground for elevation. So you can tweak the amount of elevation at runtime, which is easy enough. And you can also change the size of the shadow and the position of the shadow on the y-axis. You could also change it on the x-axis, but it's kind of pointless because as soon as you do, you get artifacts, so I didn't really do that. You can also, in Android P and later, and only in Android P and later, change the color of the shadow. So you can set the color, you can set the opacity, and all that stuff. You can do it both for the spot shadow and for the ambient shadow. And then you can end up with something looking very, very weird, like this. Don't do that. But yeah, the idea is that that's your playground. If you want to see how things would look, especially if you have designers that are like, oh, elevation, I want to do elevation, just give them that app and tell them to find something that doesn't look like crap and is closer to what they want, so they can actually realize what are the compromises that they need to make. And the app is also on Google Play. If you're lazy, just search for Uplift. I think it's the second or third result. Damn squatters. One last thing before I let you go. Now we control everything in the elevation shadows. We can be evil. We can color some of the shadows, or we can animate the color of the shadows. You can animate the translation Z, which is the elevation, and you can also animate the color and the alpha. Don't do this at home. The ultimate hack is to move the actual position of the spotlight. That's determined by theme attributes. Don't do that. Please don't do that, but you can. You cannot move the ambient light because it doesn't have a position, but the spotlight you can. And there is literally, again, literally no reason to do this. Please don't do it. But if you wanted to play around, we can have fun. You can move stuff and make all the shadows look weird like that. And you can have like a inception moment and be like, whoa, reality is bending. But yeah, this is actually quite simple. I'm waiting for the slide to advance. There you go. There's private themes attribute you can use. You can set the Android Light Y attribute in your theme, and that's going to change the position of the spotlight. There's an asterisk before that because it's a private attribute. AAPT will break your build if you don't put that. That's basically a hold my beer asterisk. Seriously though, don't do this. Please. It can break at any time. And you cannot get anything interesting out of this at all. So again, do not do this at home. Please, I don't want to go out and see people doing this just because I said it's possible. Don't do that. It's not a good idea. And that is all. I don't think I have time for questions, but you will find me around and you will find the slides there at some point after I have had lunch.